Okay, now we're gonna wind some pickups. Get junk out of the way. I'm using 42 gauge wire, American wire gauge, AWG. This is nylon, the solderable nylon insulation. And I'm putting this in a bucket. Get it down on the floor. I had a piece of tape that decided to run away. I'm going to tape that right here for right now. This is my winder, which used to be a Shatton winder, which has been totally rebuilt. It's basically just the box. It has a DC direct drive motor now, and a speed control. The original speed control in the Shatton winder died, and they wanted me to send the winder to Canada, and then they talked me into I thought it was the motor, buying a new motor from them, which was a very underpowered little DC motor, and that didn't fix the problem. And it was actually the kind of homemade speed controller, which was just like a voltage regulator kind of thing. It wasn't really a real speed control. This is a real speed controller here now. This counter sucks. I can't really see it depending what the angle is. So I'm replacing that with an LED one. I'm going to paint the whole thing and refurbish it a bit. But here's our bobbins. This is not really a course on how to wind pickups, but I'm going to show you how I do this. And, I will have videos in the future to get more in-depth. Because these are plastic bobbins and not the fiber bobbins like you would find on a regular Fender pickup, they don't have the little eyelets to solder the wire to, so I'm using 28 gauge hookup wire, just like you would use on a humbucker pickup. And that's the way I'm going to do these. They do have holes, the bobbins. I've sanded off the flange, so there's still a couple of holes, and I suppose eyelets could be pressed into those, but I would speculate that soldering those would melt the plastic, so I'm not going to do that. So I'm using white wire as the start wire and black wire as the finish wire. That's what I do. Everybody does things a little differently, and this is the way I do it. So I have 4 of each here. I'm going to wind these first two pickups. If I was doing a regular P-base pickup with the fiber bobbins and the eyelets, it would be essentially the same thing, only without this hookup wire. I have my soldering station set for 400 degrees, which I believe that's Celsius. It doesn't say, but that's what I think it is, and that will melt the insulation on the wire. I don't sand it or do anything like that. You can use a disposable butane lighter if you want to do it that way and quickly, pass it over the wire. I just solder it, and that always works. So this is pre-tinned wire. I'm going to add a little solder to it. If I can get my fingers to actually work. There we go. This kind of shows that you don't need a really elaborate winding setup. I've wound hundreds of pickups on this thing, both in its original state and the way it is now. It does not have a reverse motor function because I don't wind in reverse usually. If I really have to do that, I flip the bobbins over. And a little background in that, the reason why, like if you wind a guitar humbucker, like a PAF type of thing, you wind both coils in the same direction. The reason why Fender started winding the middle pickups on Strats in the opposite direction, because they didn't used to, they were all the same, is on a regular Fender type pickup with the fiber bobbins, the wire is touching the magnets. The magnets are not grounded. If the start of the coil goes to hot and you touch the magnets that are not grounded, you will get a humming, buzzing noise, because you will induce noise into the magnets and then into the wire. So because of that, it's good practice to have the start of the coil to be ground. That way, if you do touch the magnets, it shunts that noise to ground. Now, the middle pickup on a Strat is wound in reverse so that they could keep the start of the coil at ground. You don't have to do that if the pickups are covered. On a Fender Mustang, the pickups are covered because there's a phase switch, you reverse the polarity, and you could end up with that humming issue. So that's the reason why that's done. So I don't really wind in opposite directions. The Shat winder originally had a platen on each side. It doesn't have that anymore because it's direct drive now. There's a DC motor in there. So this is the way I do it. And I'm just using double stick foam tape. I don't have fancy. I do have some little things that hold certain kinds of bobbins, like if I'm winding like a jazz bass bobbin with the magnets in it, I have a thing that'll space them. So I'm wrapping wire, the magnet wire, around the tinned end of the wire here. And I don't know how many turns that is, but that's about what I do. I'm pulling the wire out of the way. Now I'm just going to solder this. You have to be careful. If you heat it up too much, the wire will break. You get a feel for it after a while. Once in a blue moon, I have a pickup where the start lead did not get a good solder connection here, but that's kind of rare. It sucks when it happens because you have to wind the pickup over again. But see, I'm just heating that up, and I can tell by looking at it, it's nice and shiny. And that has melted off the insulation off of the magnet wire. There's nothing more that needs to be done for that. I'm just going to clip this a little shorter. And that's it. That should be a good connection right there. I'm going to wind a couple more turns on here just for mechanical strength. And because these have magnets in them already, they just collected some steel wool dust, which I do not want in there. Let me get that out of there real quick. Wouldn't hurt anything, but you know, it's not something you want in there. So what I'm going to do is, my winder is winding in this direction. I actually have an arrow normally drawn on there, which isn't on there anymore, to remind myself. So I'm going to poke this wire out one of these holes. There's a hole in the bobbin here, and I'm going to bend that over a little bit, and it's going to go that way. So we're going to wrap a few wraps this way, and I'm going to get some tape. Just hold it here with this thing here. Got some paper tape. If you do wind Fender style pickups with the exposed magnets, you should really tape off the magnets. Fender didn't do it, but they also had lots of pickups that would fail after many years of Alnico magnets. As the name implies, the al part is aluminum, or aluminium if you pronounce it that way. Fun fact, the scientist who discovered aluminum named it aluminum, English scientist, and later it was changed to aluminium because aluminum sounded too old-fashioned, they thought. They liked the ending of the inium instead of aluminum, which was like alum. Everything had that kind of ending. But anyway, here we got our wire. But if you do wind Fender style pickups, you should put tape on the bobbin, on the magnets, because you will get a the aluminum and the copper, even though the copper has insulation on it, it will break down eventually, and you have what Seymour Duncan called intercoil corrosion, where the wire corrodes and it breaks. And a lot of this is because of like moisture, sweat, and things getting in there. Leo Fender actually patented wax potting as a way to stop that from happening. So I have my guides set here. Actually, they're already set to the right distance. I don't know if they're far enough in. So let me try doing this. I don't think it is. I think that has to move over a little. No, actually, that looks good. All right, so a P-bass pickup has 10,000 turns of wire. So that's what we're going to do. A little background on the design philosophy of this bass. I had wanted to build myself a P-bass because I like P-basses. And I just wanted to use, I've been making magnets for years with neodymium magnets and all kinds of things, and I wanted to just make regular P-bass pickups. These have regular Alnico magnets in them. I stuck the magnets in here already just for the heck of it. But I may do some different things. I'm not sure yet. I do have if I can get them off the thing here, I do have little neodymium magnets that would fit into the bobbins, which I could try. But I don't know if I want to do that yet. But, I can put different pickups in the future. Right now, I'm making pretty much stock P-bass pickups. And that should be good. Now it's just a matter of winding. I do not scatter. You see people doing these very exaggerated back and forth motions, and all you're going to do is make whoa, and I broke wire. All you're going to do is make a really sloppy coil doing that. And my wire got hung up here on my spool. I don't know why. It happens, unfortunately. So we're going to start over. Okay, so I have reattached the wire on here. I'm going to change how this is coming out. I'm actually going to drill a hole close to the end of the flange here, so there's not so much of the hookup wire sticking out. I use my Dremel as a very small drill. So now when I do this, oh, come on now. I got a lot of wire sticking off there. That's okay. It is hard to see this a lot of times. If you're just starting out winding, you have a hard time seeing the wire. Don't feel bad, because I have a hard time seeing the wire too, and I've been doing this for, I don't know, 30 years or something. I dropped my wire. Let's try this again. Alrighty, so I'm going to thread this through this hole I just drilled. As soon as I find it. There it is. See, now it's coming out much closer to the bottom of the flange of the bobbin. I'm just going to bend this over with some hemostats here. I'm going to tape that down. This is just thin paper tape. You can get this in art supply stores, and I think they consider it drafting tape. It's paper. It's also nice for putting on the outside of bobbins that you want, pickups you wind. It looks good. That's coming out of here. Alrighty. just a straight piece of wire. I'm going to cut off. What I didn't show is when I cut the wire off that had broken, I use surgical scissors. They're really good for getting in there and snipping off that stuff. Hopefully, it doesn't get stuck in there. I don't know why it got stuck on the spool. I had it inside a bucket, now I have it on top of the bucket. Let's see if that helps. I'm just gonna do a little of this by hand. We only got to like 200 turns before. Look, there it is getting stuck again. And there it is getting stuck again. Why is it doing that? A piece of tape don't help. The very big spools are sometimes a pain. Okay, I think that's feeling good. I'm going to start kind of slow. What I was saying before, I was so rudely interrupted by wire breaking. Let me secure that piece of wire sticking off the end there. I don't scatter. You see people doing this very exaggerated back and forth. And what you end up with is a really loose, sloppy coil. And I don't think anybody really ever wound that way. And then you have, big commercial winders use machines. And they don't wind like that either. So what I do is, I just do this as neatly as I can. I'm not paying attention to turn count, turns per layer. I think is, if you're winding by hand, you can't possibly count that, and I'm not even going to try. And the other thing is that, like, winding patterns, people think, well, the winding pattern matters, how the pickup sounds, and you can wind 50 identical single coil pickups. We'll say single coil because, there's one less coil to think about. But let's say you make 50 strap pickups. You wind all of them to 9,000 turns. And you're winding them by hand. And this is random. No matter what I do on this, I cannot absolutely repeat the way I'm laying the wire down here the next time. And those 50 pickups will sound the same. There won't be anything drastically different about any of them. So I think all this stuff about people worrying so much about you have to have, and then if you're scattering on top of it, you're doing an even more random coil, and you're getting a lot of very long diagonal wraps and stuff. I just think it's that's kind of nonsense. This winder can go much faster. The problem is this particular counter starts to lose counts. If I go much past this speed, I am going to be replacing the counter. And this is using, I guess it's a reed switch. There's a magnet on the platen that the bobbin's on. And it can only go so fast, and it starts to bounce, and it just stops counting. So this is about how fast I go. We're at 2,800 turns, and pickup winding, you wind to a fixed number of turns. You do not wind to resistance. Resistance is kind of a side effect of how many turns. You know, nobody ever designed a pickup, oh, I want this to be 8K. No, they didn't do that. They might have wound 7,500 turns, and it came out to 8K. And, you know, if you look at pickup, this is 10,000 turns of wire. Why 10,000? Why not 9,568? You know, it's because it was a set number. They just came up with a number. A good example of that is a P90. A lot of them are 10,000 turns. Not all of them are. Some of them are less. But a lot of them were 10,000 turns. And around the time when the humbucking pickup was designed, Seth Lover figured, well, you know, we're going to make basically a hum-canceling P90. So they took the 10,000 turns of a P90 and he divided it into two. So each coil on a PAF has 5,000 turns of wire. And that was it. There was no magic involved in there with the number. We're at 4,200 now. Takes me about 10 minutes to wind a coil at this speed, which is okay. It's kind of meditative. Every now and then, I might stop it and look at it and think, oh, that's, you know, that's going down nice. I don't really pay attention to it. Because I've been doing this, obviously, for, like I said, 30 or 40 years, off and on. So I just, you know, you get used to it. I'm holding the wire in 3 fingers for tension. I'm squeezing not too hard. If I squeeze too hard, I cannot stop this motor. The old Shatton winder, you could actually stop the motor by squeezing the wire hard. In this one, it would break the wire, or you'd stretch the wire. So I just have a good feel for, you know, how it feels. And I'm up against the bottom of this little guide bar, and I'm going between these 2 little guide bushings. We're at 5,200 now. Leo Fender used on his winders for a drive belt, he used a rubber band. And the reason was the rubber band would slip a little. And when he set up his new winders at G&L, they also used rubber bands. He said that was part of his secret for winding. This original winder had was belt driven. This is direct drive, which has a lot more torque. You could not stop that with your hand without hurting yourself, which is kind of surprising. So we're almost at 6,000. No, we're at 6,000 winds now. So it's just, you just do this. It's, you know, like I said, it's kind of meditative. I used to do this all day long, which gets monotonous. I started to build a CNC controlled winder, which I just never got around to. But I mean, like, it's like anything. This is, you know, you could use a CNC to carve your guitar neck, or you could do it by hand. It's kind of fun doing it by hand. It's more work, but it's enjoyable if you like doing it. And this isn't so bad. But there's nothing magic here. You find if you make your own pickups, the very first pickups you make, unless you did something wrong, like have a short or a break in the wire, you can have a break in the wire and the pickup still works, which is a funny thing depending on where the break is. We're at 7,000 turns now. But it's your very first pickups will sound good. They'll sound like what you're expecting them to sound like. It's really not rocket science. The thing where it changes is the design of the pickup. I worked at DiMarzio for a while, and you know, people don't realize all the parts in their pickups are really very custom. The pole piece screws look very normal, but they're not. They use lots of very custom parts, but it was the design that set it apart. A lot of people just copy what Fender and Gibson did, and they just keep repeating that over and over again. And I think that's kind of boring. Now, I am winding a Fender P-Bass pickup here. I'm not doing anything unusual. And like I said, in the future, I may decide to change the pickups and put something more unusual in there. But right now, I wanted to see what this is like with regular stock P-Bass pickups, except I have plastic bobbins because it's easier. We're at 8,200 turns now. So, you know, getting back to turn count, you don't wind to a resistance. I will check the resistance of this coil when it's done so I have a good idea whether or not the coil's good. P-base pickups usually about 11 or 12,000 ohms, so this should be about, you know, half of that, 6,000 or so. We're coming up on 9,000 turns, but it was just kind of random. I think, you know, people picked. Seth Lover has once said that they wound the PAFs until the bobbins were full, which he probably figured, you know, they designed the bobbins and they held about 5,000 turns of wire. It's kind of hard to get much more 42 AWG gauge wire on a PAF bobbin. At that point, you have to switch to thinner wire, like 43 or 44. We're at 9,600 turns. 97. And I'm just going to watch this as we get to 10,000, and I'm going to stop it. 98. 99. And bingo. 10,000. 10,006 is what we have. And this is what our coil looks like. It's nice and fat and juicy. These bobbins are a little taller than a real P-base pickup. They're kind of squat, but that's kind of how they do them these days. So, next step is to attach the other wire. And we came out on that side. So, I'm going to take one of my black wires here that I have stripped. And I'm going to tin this. I'm going to do the same thing I did before when I started this. And I want this to come out on the same side, so I'm going to kind of do it from there, like that. And I'm just wrapping this around the wire that I just tinned about this many times. I'm kind of going in a straight line. I'm not bunching it all on top. It doesn't really matter, but that's probably a better way of doing it. And now we're going to solder that. I kind of solder it until, I shouldn't have my arm in the way. You start to see the wire got a little soft and the flux starts to bubble, and that should be it. I'm gonna break off this loose end and tape it down here, and we'll get, you would think I would have this prepared, wouldn't you? Get my meter out. It's my old trusty Radio Shack meter with stickers that my daughter put on there when she was little. And let's see what we got. It's 5,029. There he goes. So that's a good coil. And that wasn't hard at all. Now I'm going to, I have other tape here. I'm going to tape up the end of this and tape it into the coil. And then we're going to drop that in, that's too, we're going to drop it in the wax. Usually I tape down the loose end first, which I didn't do. So I'm going to do that first. Bring it around this way. I lost my tape. I'm also laying the tape against the coil so that when I lay this tinned wire end, I'm laying that on the tape and not directly on the wire. And I'm going to stick it out one of these holes on the bottom that were already in the bobbin. And I'm going to wrap some more tape around it. And I'm using the purple because I like it. Like that. And like this. I'll burnish it down a little with my fingers. And here we have our wires coming out the bottom of the coil. Now I am going to wrap a rubber band around this from the bag of rubber bands. What's a suitable size rubber band? Maybe we'll try one of these little ones. Some of these rubber bands are old and they break, but that's okay. So, yeah, I want to get it on the tape. I'll do another one. Rubber bands are cheap. That one's big. Well, see, that's what I'm talking about. Breaking rubber bands. I want to keep it on the tape so it stays on. So here I got some rubber bands on there, and I'm going to drop it in my wax pot. This is a paraffin warmer made by Gigi, which is intended for people to put their hands in there, or their feet, or whatever. But this is what I use. It has paraffin wax. I do not use beeswax. And I'm just dropping that in there. And that's going to sit in there for 10 minutes. This is very much a rinse and repeat situation. I have my other, starting the second coil now. As I mentioned, I'm winding these in the same direction. You can either do them opposite directions or the same direction, and it works either way. The only difference would be how you wire them up. So as in the case with a PAF style humbucker, both coils are wound in the same direction, and you wire them up start to start or finish to finish. So they're wired reverse polarity because the coils are wound the same way. If you wind your coils in opposite directions, you wire them up in phase. So you wire them start to finish or finish to start, because the reverse winding of the coil changes the polarity. And the way that a humbucking pickup works is because the two coils are electrically out of phase, they cancel common mode noise, which would be hum, that comes in. But because the magnets are opposite, that reverses the polarity of the signal from the strings, and then the reverse coil polarity puts them back in phase, and everything sounds good. And that's how that works. Because the noise doesn't require the magnets to be sensed by the coil, to be inducted into the coil. But the strings do. The magnets, another fallacy about pickups. The pickup does not cut through flux lines in the magnet and all that stuff. I mean, technically it does, but that's not how it's working. How it's actually working is the magnet magnetizes the strings. As long as a steel or, ferric metal, steel, iron, whatever, is in the presence of a magnetic field, it's magnetic. You can, you can see this for yourself if you stick a magnet on a paper clip, and then the paper clip becomes a magnet and picks up things. Now, if you remove the magnet from the paper clip might retain some of that magnetism, and you can still pick up things even though it's not in the presence of a magnetic field. But your guitar strings become magnets. And they actually, you can remove the magnet from the pickup, and your strings will still pick up sound. I have a short video of that, which was done very crudely with one hand. I didn't have a tripod set up or anything like that. I will do a better video of that, but I took a PAF pickup coil, hooked it up to an amplifier, and had no pole pieces or magnets in it, and I took a bar magnet and I magnetized a section of string, and I held the pickup over it, and you could hear the strings, because that's how it works. It's not this strings disturbing the magnetic field and stuff. Now, the magnetic field is always there. The thing is, it's the Faraday paradox. You cannot have, if the coil and the magnet are not moving in relationship to each other, they cannot generate current. If you take the coil and you take a magnet and if I grab a magnet, I have lots of magnets. If you take the coil and the magnet and you move one or the other, you'll generate a current. If they're together, no current will be generated. However, if steel passes in front, that becomes a magnet, and it becomes a moving magnet pickup, much like a lot of stereo cartridges and things are moving magnet. That's how it works. Speakers, the coil becomes a magnet and it pushes in and out against the permanent magnet. Now, it's kind of a moot point because the pickup will always have permanent magnets in it, but they are magnetizing the string. That's is actually how it's working. It's not any of this other stuff that people talk about. But it's kind of is and it's kind of not. It's kind of the same thing. I'm going to start winding this. My timer will be going off to get my bobbin out of the wax. I leave them in for 10 minutes. That gets the wax penetrated all the way down into the coil. I know this because I've cut coils apart that were bad, and the wax was all the way in there. I do not believe that not waxing pickups makes them sound better. You'll just squeal. I've, made prototype pickups, listened to them before they were wax potted, and then I wax potted them, and, if they're picking up vibrations, which you don't want them to do because that's how they squeal, it's negligible, and you're really not going to notice it. It's just kind of a bunch of nonsense. So I'm doing the same thing I did before. I just go back and forth. Now I find that winding, especially for bass pickups, winding a neat coil gives you a tighter low end, and it's a better sounding pickup. The big spongy coils made by overly scattering the wire just can sound mushy. They can have a mushy low end, and it's the same kind of thing. And I get a better sound, I think, out of neatly wound pickups. I don't think hand winding is anything special either. I hand wind because that's what I have. At some point, and if I was making more pickups, I don't make as many pickups as I used to make when I was making pickups full time, but I would have welcomed an automated winder that once I got my, number of turns I wanted and set my parameters, it's nice to be able to push a button and it does that. As I said, I worked at DiMarzio. They use automated winders. There is a person sitting there while it's doing it, so it's not totally there's nobody involved in the process, but it's kind of setting the bobbin up into the machine and setting the number of turns you want and all the other details that they had for each pickup, and then they let the thing go. And then they would test it when it comes out. And then later on they would test the pickup actually on an oscilloscope and things like that to, every pickup had a, Okay, my timer went off while I was winding. So we will get a pickup out of the wax and we'll take a look at it. Just take it out and I let it drip a little bit. And I got it on a piece of paper towel. Just to sop up the excess, and that's our freshly wax potted coil. Just wiping the excess. You don't want a whole lot of wax on it. Set that over and let that cool off. And we will continue with number 2. see my coil's a little... Well, actually it looks good. I thought it was a little fat in the middle. That's just where the wire is. You want to look at your coil every now and then, and if it's too bulgy in the middle, you can concentrate your winding more on the ends like this. You can hear the sound if I squeeze a little more, squeeze a little less. It does change the speed very slightly. You don't want to squeeze too hard, but you don't want your coil to be loose. I didn't tape up that loose end, but it's okay. You have to watch these. The loose wire sticking off there can snag things, but it's not near where I'm winding. And we're at 47, 48. See, the last one was a few turns over 10,000. It doesn't make any difference. You could probably go 100 turns over your number, and it's not really going to make all that much of a difference. You know, when I'm prototyping pickups, sometimes I'll pick a number that I want to wind to based on maybe things I've done in the past. And you can get an idea if you want it a little hotter, a little less hot, and 500 turns would make a difference probably in the way a coil sounds, especially if it's two coils like a humbucker, because then you have 1,000 turns right there. But 20, I see people's numbers where it's like 9,220 or something like that. That's just kind of silly. But if you do something and you like it and you want to superstitiously stick to that exact number, then by all means, just do that. The other thing to remember is when you read the resistance on a freshly wound coil, the fact that the wire is sliding through my fingers with some tension, some resistance, is actually making the wire warm. So the reading I got from it right after I wound it is going to be higher. The DC resistance rises with temperature. So it's going to be higher than if it sat around a while. Also, if it was hotter in my room here, say it was, 90 degrees Fahrenheit on a hot summer day. I don't have air conditioning in here. As you remember earlier with the fan in the background. It will read a little higher than if it was a cold winter day and it was 50 degrees Fahrenheit in here. Right now it's 68 degrees. And then also, once again, taking the coil out of the hot wax, the coil's obviously very hot. That's going to be higher. The thing with wax, I've seen people where they preheat their coils before they put it in the wax, figuring, well, to make the wax penetrate. And I think that's also totally unnecessary, because just having the bobbin in the wax, the hot wax is going to heat up the bobbin just as if you preheated it in some kind of an oven or something like that. You're not really doing anything. I mean, are you saving some time? Not really, because it's, if it's sitting in the wax for a minute, it's going to be hot. The whole thing's going to be hot. And the wax is going to penetrate. If you stick the whole bobbin in there for 30 seconds, or maybe even a minute, the wax might not get in there. You can see it when you put a cold bobbin in, the wax gets kind of white looking around the outside, but that doesn't last long because everything, the wire, and in this case there is magnets on it, all that is getting hot. It'll end up the same temperature as the wax. So there's no need in preheating your bobbins. I'm not sure who came up with that idea. A lot of things are passed down, and because people don't really understand how it works, it becomes kind of like folklore. Like, I don't use beeswax, I just use paraffin. The big pickup makers don't use beeswax. There's different grades of paraffin that melt at different temperatures. You can get some candle wax that's very, very high temperature, and I got some once and it was terrible using for potting pickups because it had to get really hot to melt. The stuff I'm using here in this paraffin warmer is not so hot that you can't stick your hands in it. It's over 100 degrees, but it's fairly comfortable. The wax, it has paraffin oil in it, so it's made to melt at that temperature. Good thing about this is it will not distort your bobbins. I used a small crock pot one time and I melted my bobbins trying to melt the wax. And if you're melting your wax on a stove, you have to make sure you use a double boiler because the wax can catch fire. You don't want to do that. I think the safest way is to use these paraffin warmers. Squeezing the wire a little harder as I'm talking. Because I can leave that on all day long, all week long, and it'll maintain that temperature that it's on high, right? And it's probably 120 degrees Fahrenheit. I'm at 98 here. 99. 9999. And we're at 10,016. Because I went a little over because I'm talking. And there's coil number 2. And we're going to do exactly the same thing now. I'm going to tape that little stray end down first. You can see it's a nice, bit of a different shape there. It doesn't really matter that much. Some of that is because there's a little bit of this wire in there and it kind of makes a bulge. But it's not rocket science. It's actually very simple. If you've never wound pickups, if you're just starting to wind pickups, you'll find that it's things come out well. There's a lot of mystique around different people's pickups, and there are some pickups that are very, very unusual on the inside. Like lace sensors are very unusual on the inside. They're really doing something different. Bartolini pickups were always very unusual on the inside. He had multiple coils and he had trapezoidal pole piece tops and things like that, and it was all for specific reasons. But your average everyday pickup these days is rather boring, and it's just kind of like this. It's wire wrapped around some magnets, and that's kind of all it is. There's nothing unusual going on. I make some pickups that are a little more unusual on the inside, which is kind of from trial and error, trying out some different ideas and seeing what they do. But when it's at the end of the day, you're wrapping turns of wire around magnets, or steel pole pieces raise the inductance, so that's that plays a part in it. If you look at, lots of pickups use steel pole pieces. So let's get a reading here. Where did I put my needle? If you watch enough of my videos, you will learn that I am notorious for losing my tools 5 minutes after I use them. And you can blame ADHD for that. So what do we got here? We have, this says 5,007. So reads a little less than the other one, even though it has a little bit more turns. Or maybe the other one was a little higher. I don't know. It doesn't really matter in this particular case. The small difference between them won't change a thing. It also will not affect the hum canceling abilities. You can get, there's a some old Bartolini pickups. I had one. It was a mini humbucker, and one coil was about 3,000 ohms, and the other coil was like 4,000 ohms. It was that far apart, and he did that to bring out more high end, because humbuckers, like a regular side-by-side Gibson kind of humbucker, will have phase cancellation of the upper frequencies, which gives them a little bit fatter sound. And that's why you see people offsetting their coils, although most people only do it by a ridiculously small margin, which I don't think does a thing. Like I said, like 20 turns or 100 turns, or probably won't change all that much. But that's the reason. The reason is you don't want to, if your two coils are slightly different, they will, you'll retain more high frequencies. Another way to do that, which was an innovation of DiMarzio's, is to wind your two coils on a humbucker. You wouldn't want to do it with this kind of pickup, because these are essentially two single coils next to each other, the way they're picking up the strings, but you can use two different wire gauges. So you can use 42 on one coil and 43 on another coil, and that'll make the two coils sound a little different. If you wind a coil with 5,000 turns of 42, and you wind another one with 5,000 turns of 43, the 43 gauge wire will read higher resistance, but it won't be louder because you did 5,000 turns. It's the number of turns that matter. But they will sound a little different, so the resonant frequency will be a little different, and you'll have less of that phase cancellation. And that one goes in wax for 10 minutes, and I will continue on with the other two off camera. So we have both pickups wound. Our neck pickup comes out to, just looking up temporary look at it, we have 10K, which is typical of a P-bass. I decided to wind the bridge pickup at 11,000 turns, and this one is reading 11.8K, almost 12K. I'm also going to do the DiMarzio treatment on this one, and I have steel poles and ceramic magnets on the bottom, so I think I'm going to do that for a beefier bridge pickup sound. And I'll see how it works in the bass. I may decide to change it to something else. And now I'm going to make the tops for these pickup rings that the pickups fit in. The pickup body, actually, not the ring. And that's what we're going to do next.